Eric Hexter joins us live in studio on the Azure DevOps podcast.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome back, listeners, to the Azure DevOps podcast. Go online to azuredevops.show to see show notes and other episodes. Eric Hexter joins us today. He is the CTO of Quarterspot LASO, a fintech company that produces lending platforms using machine learning. He built the company in the cloud with DevOps as a foundational component of delivering the product. Eric has filled roles as CTO, chief architect, developer, and consultant. He spent most of his career working with web technologies and remembers writing tables by hand in Notepad. Eric, how you doing, man?
Hey, I'm doing great.
HTML tables, right?
Yeah, absolutely.
That's
before IntelliSense existed.
Before IntelliSense, wow. Front page was pretty good in the late 90s,
yeah,
though.
Yeah, it was okay.
It
was okay.
1998. Front page 98.
Yeah, so I think I was using Notepad all the way up through 2001, maybe 2002.
Yeah, not even Notepad++.
No.
Awesome. Well, hey, it's been a while since we've chatted. This is your first time on the podcast, but you're, in my opinion, you're a DevOps king. You did some really awesome stuff just over the past decade and a half at other companies before, and I think you've written some books too. Yeah,
I have some books. That's something on ASP.NET MVC. You may have heard of it.
Now, for the listeners, Eric and I co-wrote a book, a handful of authors, back in the ASP.NET MVC full framework days. But we're talking about DevOps Diagnostics today. Mm-hmm. And so before we get into the content, how did you get into really diving into this topic? What was your world like that caused you to say, hey, this stuff is important?
It really goes back to, I guess, some of my first serious gigs. If I go back, we were kind of joking about writing tables in Notepad in 2001, but even back then, I was doing some pretty large brand consumer sites, and most of it is, we had some system engineers that were, working for the IT department, but our online department, which was tasked with, building the brand online and making sure all of our technologies and our assets were online, that still kind of fell to us. So, since 2001, I felt like I've been responsible for keeping things online, and I've always fell into the place where I felt I was kind of the watchdog to make sure our availability was online, performance was online. So, although I was also lead developer on a lot of those projects, I guess I was doing DevOps before it had a name, but it was really, doing the development, but also making sure everything was performing as expected.
Yeah, and keeping it running, preventing possible bad things.
Yes,
can happen
absolutely.
Instead of just a post-mortem after it did happen.
Yes.
So you recently did a presentation to the online Azure DevOps User Group, where you kind of laid all this out. And so if any listeners want to go just do a search, user groups up on meetup.com, Azure DevOps User Group, full video presentation. It was phenomenal, actually. But let's just hit the high points. So you got software built in Visual Studio. Now, all of this, does the software need to be running in Azure, or does it matter, or does it favor it?
Yeah, so we built it for the cloud, but kind of going into it in 2013, I wasn't sure which cloud. So we made the choice to go IaaS, so virtual machines, stuck with common data providers, things like that. So we didn't build PaaS, so we decided not to tie ourselves to a specific cloud, but to be independent. So that being said, it could run on-premise. There are some things like, we use Azure storage, right? I'd have to figure out an abstraction for another file system, but for the most part, I feel like it's pretty independent.
Okay, so a lot of virtual machines, but you're still using the PaaS storage components.
We are.
Gotcha. Okay, but if someone has no virtual machines, in my mind, there's less to monitor, right? Yeah.
There's a subset of things that go away, but I think in terms of DevOps, and I like to focus most of it on the application running and not the infrastructure running. Yeah. The infrastructure is kind of like, you can look at that and say, okay, yeah, it's using a lot of memory or a lot of CPU, but where do you go next, right? It's that double click down, okay, what is using those resources and why? And that's really where I think really the value of this diagnostics data comes into play. It's actionable.
So some people might be using New Relic or Stackify or even Application Insights, but maybe they're looking at CPU and memory consumption and whatnot. Are you saying that if they're just watching the infrastructure, then they really aren't watching their application?
Yeah, I mean, ultimately, it's I've used those tools in the past as well, and I still look at CPU and memory because you never know when you could introduce a memory leak, or a update to Windows could introduce a memory leak. Or a change to the framework. So those are things you still have to monitor. But when you're really talking about a enterprise-grade application, you have to go a level deeper than that.
All right, so lay it on us. What is Cloud and DevOps Diagnostic consist of?
Yeah, so I really like to think of what is it in terms of you hear about telemetry, you hear about diagnostics, you hear about all these other tools. I really think about it as the metadata around the operation of the system. So that goes, as we said, from the server level, but down to more specific things. So if you're creating a modern cloud-based architecture, we're probably using message queues or service buses or other mechanisms to help decouple your front end and your back end work, right? We're talking about, do you know exactly how many messages you're processing? Are they overloaded? What's the ramifications of scaling up a specific message in terms of back end technologies? If you're using SQL, if I scale up a message queue to use 1,000 workers, what does that do to my database, right? It's all interconnected. So in order to be able to operate your systems effectively, you really need to understand how can you determine correlations between each of your components in your systems.
Okay. So what does that boil down to? What do .NET developers need to be watching? What are the categories?
Yeah, so I kind of break it down into just a handful of categories. I do system metrics. And I'll just run through them. We can double click into each of those later. System metrics, log files, I think is the just kind of the basic things. From there, you have errors and exceptions. I have a subclass of that which I call fatal errors. From there, I also do things like heartbeats to know everything's running. And then there's another one that we use, which is data integrity, and we can talk more about that. But that gets into supporting kind of a real DevOps workstream, continuous delivery. And then kind of the final one, and I think the most advanced one, is really getting into structured logging.
Okay. So we just go from the top, and if we're looking at the metrics, are there particular ones that are your favorites?
Yeah. So we kind of talked about for system metrics. If you're talking about servers or even PaaS that expose some of this data, we're talking about CPU usage, memory usage, and we're talking about that both at the server level, but also at a process level, because in most advanced applications, you're talking about either Windows services or microservices, Docker containers. You have to kind of get down to the process level. If you're doing something that's multi-threaded, you want to know how many threads are running. looking at your thread pools, because all of those are indicators of when something goes wrong or something's not running as expected, right? Those are all clues. Going kind of away from servers, I talked about messaging. Some of the important messaging metrics for me are how many messages are waiting to be worked, right? And I look at that as a total number, aggregate of all your message queues. But then I also monitor, because not all queues are created equal. And what I mean by that is if you have a queue that's executing some work from your front end that needs to be executed kind of quickly so that your users get to eventual consistency sooner versus a back-end process or a nightly task. It needs to get done, but the time frame or the SLA for execution doesn't really matter.
Yeah.
So it's good to have those metrics on how many messages are currently in the queue to be worked per message queue, as well as knowing how many actually did get executed. I like to look at those across time frames. 1 minute increments, 5 minute increments, things like that.
Because if it changes wildly right after a release, something probably went awry.
Potentially. I mean, I'm assuming, in our case, we release really frequently. So new message queues are popping up.
Okay.
Old ones are going away. But what I don't want to see is some messages being stuck.
Yeah.
It means something happened in the system. We maybe got rid of a queue, but maybe that work needed to be done. So maybe that needs to go to our, the engineers to just finalize that work. Kind of the other thing on messaging is poison message or dead letters, right? So if a message would try to be processed and it couldn't be processed, you typically put that somewhere. And you don't want that to just sit somewhere and nobody monitoring it. So keeping metrics around that, so what's normal. Are you seeing a rise in dead letters for a specific queue? Are they getting better, right? Did you put out a release that you expected to fix some problems?
Now, you're talking a lot about messaging, and when people think about services or service-oriented architecture, for the listeners who haven't done any queue-based processing, can you give a little rundown just so that they can kind of align these metrics?
Yeah, absolutely. So for kind of queue-based processing, and it's interesting, if you go online in Azure and some of their architectural guidelines, they kind of talk about, there's a lot of details into why to use messaging, and there's also equivalent variations of that in some of the other cloud providers. But the idea of using a queue is rather than do a lot of work, say in a web app, somebody clicks a button, and let's say then there's a massive process that could take, say, 45 seconds to 2 minutes to execute. The last thing you want that to do is run on that thread inside the web server, because there's built-in timeouts to make web servers close down threads quicker. It ends up blocking other work in the web server. So a good pattern to use is to receive your message or receive your work, your post on your web server, quickly take that an idea of your parameters for what needs to be executed, drop them onto a queue, and now you can return back on your web server back to the user saying, hey, we're about to do this work for you. We've received it. So as far as the user experience, it's nice and quick and light and fast. The work that went into the queue now can be picked up by some back-end process. I've typically used things like Windows services to monitor these queues, but there's a lot of new eventing technology in Azure specifically, where, hey, if a message drops, I can fire off a serverless function, or I can use an app service. There's a lot of various ways to handle that work, but in terms of a pattern, it's a good way to decouple your front end from either CPU intensive or database intensive work. And
what's your favorite queue at the moment?
I keep it real simple. I'm using Azure storage queues. It's the most simple one you can use, but I don't like to use a lot of advanced features, and by so doing, I now have choices. I can move over to other queuing technology because I didn't rely on a specific feature that was only available in one.
Mm-hmm. Well, it seems like the most important feature of a queue is not losing a message,
Yes.
which is known as durability. And that is king above all else. I mean, that's really all we wanted to do.
They all have to support that. If they can't
lose a
support
message.
that, then there's a problem.
Because your system is gonna go down at some point. A data center location may go down at some point.
And I've had all of that happen.
Yeah.
Yes.
But you don't want even a single message lost.
Yeah, absolutely.
Okay. All right. So back to metrics. So I'm trying to paint this picture that you're painting. You have website. You have SQL Server database. You have multiple either Windows services or maybe Azure Functions, web jobs. Some little jobs running around, and they're looking at stuff and they're doing stuff. So you have to watch them and have metrics on each running piece of your application.
Absolutely. And you want to know how many they processed and how many that still need to be processed at any given time. If you chart it on a graph, I've seen ours over the last 5 years. I can see a problem just by looking at the slope of work that needs to be executed or that has been executed. It's hard for me to train other engineers to kind of give that same response as quickly as I can respond to it. So I've been trying to come up with more systematic ways to identify and alert of problems. But yeah, that's kind of messaging. You mentioned the one other one, which is your web servers. So I typically also look at like just user connections to web servers. And for me, that's always been important because I've always had web farms. I've always had multiple instances. And just because you have those instances running doesn't mean they're taking traffic. And that's typically, if you're going to go down, it's because you had a web farm and you thought they were all running, taking traffic. And, let's say I had 10 web servers or 5, and one was taking traffic, and that one had to restart for some reason.
That would be bad.
So it's the worst thing you could possibly do is have this expensive farm you're paying for and not have everything online and have no idea that it wasn't online.
So you thought you would scale up to a certain level, but you wouldn't.
Yeah, you wouldn't. So that gives you scalability, gives you a high availability. It's kind of all of those enterprise-y type capabilities. So that kind of rounds out what I look at from a system metrics. If I'm talking about database, for instance, SQL Azure, it's a PaaS SQL Server instance. I'm looking at things like they do something called DTUs, which is a way for them to normalize things like processor usage before they throttle you. They have the same things for memory. They have percentage for how much of the data disk you're writing to and logged. Not really disk, but the data capabilities or throughput. So we monitor those as well, and those are kind of those are what I typically think of a operations person. They would go look at, for my resources, how are my resources operating? They don't.
All right, we're going to pause real quick for a word from our sponsor.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
All right, and we're back, and we're talking about system metrics, watching how the different application components are working together. How are you actually looking at these metrics?
So for me, a lot of these are in Azure. I can use Azure monitoring. I make a nice dashboard. We're also using we've actually used a number of tools over the years. I've used things like New Relic and other third-party tools. And more recently, we moved to some more open sourcey type things like Grafana, which have some great Azure plugins. So we can just kind of plug in our credentials to the account. It can look at our monitoring accounts inside Azure and just pull in that we just look at it by resource group and resource, and we can make some nice dashboards for looking at that. So I've always been the mindset of having dashboards and having them up on screens and rotating through it so that everyone gets used to seeing them, even passively seeing them, because that just kind of gets them familiar with it. So when they're on call, they're not totally overwhelmed by all the possible things that they could look at. So,
and on your team, who looks at these?
It's really everybody. Okay. We have an on-call rotation. We have some support engineers who are dedicated towards receiving requests from our end users, and then we also have some cloud architect as well. But I kind of expect everyone to understand them, and then we have a specific process for troubleshooting and incidents.
Okay, sounds good. Well, what's next?
So next one is log files. Most basic thing you could do, and I kind of expect everybody at some point, once you get past kind of this initial MVP, if you're a startup, yes, get some basic features in there. The next kind of thing, the first time you have something you don't understand that happened in the software, is you kind of revert back to, okay, let's start putting some logging in. And it usually starts with, let's at least log our exceptions. Depending on the complexity of your software, okay, I start adding more, information entries. I might go super deep and add some like a debug level or a verbose level. But log files are kind of like the most basic thing. If I'm writing a console app, you can almost think of your log file as being your console output. But when we started getting into the cloud, and you start talking about processes running on different servers or different services, or in different locations, one East Coast, one South Central, one West Coast, your simple log file that you could execute in a console window gets way more complex when it gets distributed.
Yeah, because you have maybe 15, 20 log files. Well, one for each component of your application, multiple times location. That's a lot. Yeah.
And you may be using them in pre-production environments for test or dev environments as well. So, do you want to have a common way to expose those? If you have test discipline and they're running through, are they able to utilize those logs to make their jobs easier? Mm-hmm. So that's those kind of the basics, and I think kind of everyone gets to that level, and we'll talk about the more advanced piece a little later.
So developers are going to have to modify the code of their application to get all this stuff done. So just on log files, what should developers be logging to a text file?
Yeah, so I'm a huge fan of logging performance. If I'm looking at something running, I write decorators around most of my abstractions. I put decorators around my data access. I put decorators around my third-party API calls. I put decorators around basically anything that leaves my process, so I can then understand, okay, what does normal look like in terms of the time of execution, and then you can also log, how many retries I tried. So it's really logging things of, if something's not working, what are you going to go look for to help figure out, is it what you think, or is it some other unusual thing occurring in your software? And
for some people not familiar with the decorator pattern, what does that typically look like in your code?
Yeah, so a decorator pattern for us looks like if I was going to implement an interface, say write to a database, I had a write method. A decorator would look like the exact same interface, and it just overlays on top of the interface. So to my end code, I don't even know that there's a decorator. I'm implementing my write interface. So as a consumer of that interface, I just call the write method. Under the hood, my decorator goes in and it does a little work before it. It calls into my actual write method to my data access layer. And then right after it executes, I inject something else.
Do you like the inheritance method or the wrapper method?
I do like the wrapper method. Yeah.
Okay, so you have a new class that implements the same interface, but then calls the class that actually has data access code.
Yes.
So that from the caller, it's just the same interface.
Yeah. To them, it looks the same.
Gotcha. All right, thanks.
And then kind of the other thing of log files are some of your built-in log files, right? So IIS log files. SQL Server log files, name your data technology, it has some log files available. So it's also taking your custom application logs and marrying those together with your other infrastructure logs.
Okay. And so you have all these log files running around. How do you pull them all together so that you can have a consistent, cohesive view?
Yeah. So, that's like when you get into the cloud, that is a problem that becomes painful almost immediately. You can get away with, if you're doing on-premise stuff, you can kind of get away with, I'll go to server 1 and server 2 and I'll go grab the files. You can get away with that for a long time, but I've really looked at using basically third-party services to consolidate my logs. And in our case, we're doing multi-tenant deployments as well. So we're logging by environment, by tenant, so we can really isolate what's happening.
Because you have lots of customers on the same running instance of the application.
And we have multiple instances, but from a support engineer's point of view, I don't want them going into 15 places to go look for log files. I can give them a single place to go query the logs. They can quickly identify problems because they don't know where maybe there's some additional capabilities brought online, different services. They don't need to know where all those are. They just know there's a central place for logging. They can go look for exceptions or other warnings, and they can start pulling those up, slicing them by time frames, things like that.
So the log files themselves, you mentioned you're using a lot of VMs as well. Do you log them directly to the hard drive of the VM, or do you have a network share backed by Azure storage that you're logging to?
Yeah, so for our application, we're actually using, we kind of queue them up in memory, and then we post them over HTTP.
Okay.
So we don't even write them to disk. And as a financial services company, that's important to us because one aspect of writing a secure application is making sure that if somebody was to gain access to a system to do something, typically the first thing they also want to do is delete entries from the logs, right, to cover up their tracks. So for us, using a third-party service to post them to and get them off the box as quick as possible is pretty important. That way we can always go back and see everything that happened.
And I'm hearing a theme from how you're talking about this, which sounds like logging isn't something that's separate from the application so that we can kind of see what happened. Logging is a first-class feature that you've designed into the application.
Yeah, you nailed it on the head there. If you do build it in as a first-class feature, then you have the ability to actually do continuous delivery. And what I mean by that is we always talk about the feedback loops. I think most of the time we talk about feedback loops for continuous delivery, we're talking about feature and customer experience feedback loops. But the other component of that is the system's operations, right? If you are using a large application, either large by the amount of data you're processing or the amount of users, you have to have a technical feedback loop so that you can verify, did I affect performance? Did something else? Are we using a third party that's not living up to their SLAs? Trying to externalize that and give it to the old way of doing this was the dev team did the work, some other operations team got handed the code, and the operations team had to figure out other ways to look at that data, and it was difficult for them.
Yeah.
I think the whole idea of DevOps is, the dev and the ops is one thing. So we really want to bring some of these capabilities into the systems so that we can utilize that information to help deliver faster and deliver a more consistent code base.
Awesome. What's next?
So what's next? Air conditions. So I talked about logging exceptions, but there's other patterns that are pretty common in the cloud. Some of those are like the circuit breaker pattern, and I can kind of dive into that. A circuit breaker is, let's say I called into a third-party API, and after maybe it failed 10 times in in 5 minutes.
Yeah, because they go down sometimes.
Yeah, and they're down. So the idea of the circuit breaker is after some frequency of failures, it basically turns itself off.
Yeah.
And built in is then a time period that, okay, wait 15 minutes, we'll start using that again. But you figured out, what is the correct thing to do when that's not working.
Yeah.
So that's great from a resiliency point of view, but do you know when that happens? Right? The idea of putting that pattern in place is great, but what's better is putting that pattern in place and then also exposing the metrics around how often that occurs. When it does occur, what is the time period that, okay, yeah, let's say we waited 15 minutes, we tried again, well, it failed again. So, when it does go down, how long is it down for, those kind of things?
Because some of these, now certainly Office 365 knows that they can never go down, but there's other localized services, they just say, okay, 2 a.m. in our region, okay, we're going to have a maintenance window.
Yeah.
And so they're down. They think, 2 a.m., nobody's using it, except for your offline job that's reading messages from the queue and hitting them.
Yeah, absolutely. Yeah, so I mean, you never know. I just assume my system needs to be online all the time.
Yeah.
I think the reaction or how quickly we respond may depend on business conditions and what you've negotiated with the business, right? So on a Saturday night, we don't all jump online and make sure everything's good if we believe that.
But building this in may be the difference in coming in Monday morning with a dead letter queue of thousands and thousands of messages because they all failed versus the system's reading that outage window, pausing for a little bit, then checking back in, and then, they're back up online. Let's process these messages.
Yeah,
and then you come on Monday and there's no big deal because it recovered.
Yeah, and you have the logs, but then you also should have some analytics on top of the logs, so you can look back and say, okay, what happened over the weekend?
Yeah.
And then you have an idea of what happened versus shrugging your shoulders and saying, I'm not quite sure. So it's always better as engineers to have an answer.
Yeah.
I think that's part of what engineering is.
Yeah, good point.
So the other thing in air conditions I put in there are kind of dependency checks. So in our systems, over time, we've ended up writing checks for pretty much every dependency we have, right? Whether that be third parties, usually third parties provide some sort of really basic endpoint, which is you just validate that you can hit it and maybe you can authenticate. So we kind of run through those. We do things like against SQL, we'll do a select top 0 or top 1 from a table. So it's really quick and we know we can authenticate. We know the server's responding. We'll also do checks into like blob storage. Can we write the smallest byte possible and we see that it's written? Can we make sure we can delete it? So we kind of do those as well, and we have those running on a timer. So from the system, and again, this is the difference between having a separate operations team trying to monitor those. If you monitor those from within the system, you're using the configuration that was given to the application. Mm-hmm. So if it's a configuration error, you know it right away. And you can do those during startup and then executing them on some frequency. But if you're doing that, you can find out about an error before a user goes and clicks on a button, and that button ends up calling into that third-party service and it's down.
That's true, because the website could be up and plenty of the pages working just fine, but that one page that, for instance, needs to write to the database, it could blow up.
Yeah. And it's frustrating for users to have errors. It's frustrating for the officers or executives in the engineering department to have to kind of constantly say, "Yep, we had more downtime." If the engineering team can stay ahead of it by having these dependencies checks, a lot of times, we can discover things, get them back online before a user even tried to use that capability. So in that case, there wasn't actually any downtime.
And it doesn't sound like that technique is terribly complicated. It's just writing a little bit of C# to tickle those dependencies so that if there's a problem, an exception will bubble up and your overall monitoring tools will kind of start flashing red.
Yeah,
right?
absolutely. So the next one on top of error conditions are what I call fatal errors. And these are specific exceptions that if they occur, think of it as a as a wick that's lit on a bomb. If I see this, I know I have a very short time period before terrible, disastrous things are going to happen. And one example of this is, if you're using Entity Framework, right? Entity Framework, when it starts up, it looks at its internal meta model, it looks at the database, and if there's a difference between the migrations, it says, hey, you need to run a migration because the database is in a state that I'm not sure about what to do, so I'm not going to move forward. We have had instances where either during a deployment or something else, when I see that exception occur, I know I have until the time each of those processes restart before they become unusable. So I look for exceptions like that, core capabilities that, if I see that logged one time, we send alerts because we have to react quickly to them.
Yeah.
And there's, in any system, there may be a few of those. You could say connectivity to your data storage. If you see one of those, hey, we need to know right away. We don't want to find out later.
Yeah.
And those are, I definitely always want to separate those from all other exceptions. Because exceptions occur, you don't want them to occur. They should be exceptional, but not all exceptions are the same in terms of how quickly you need to respond. So I always want people to think about that. I have my engineers think about it. Let's go turn off a service and see which exception gets thrown. That way we can understand what it looks like. We can understand which one it is and start building some alerting around it ahead of time. That's
a good point. You're designing into the language or the domain of your system what is fatal, what everybody wake up in the middle of the night because this just happened. Yeah. Versus, there's an exception, but it's not a catastrophe.
Yeah, exactly. So it's that early warning.
Yeah, the worst thing is to have these alerting streams where people start ignoring them because there's so many false positives.
Yeah, absolutely. And it's just typically the reason why alerting always gets pushed off, or you're fatigued from so much information. So I think to your point, it is really important to have the conversation and think about that from an engineering perspective of there are a few things that are really bad when they happen. And if you're in the cloud, they will happen.
Yeah.
It doesn't matter how many redundancies they have between different data centers. I've probably experienced every kind of failure you can be between all of our different services. So it's really the difference of, can you see when it happens and respond to it quickly? And ideally, you design your system so you can fail over quickly. But failing over doesn't help you if you didn't know the problem existed.
Yeah, every single thing that runs on silicone will at some point get in a bad state and at minimum have to be restarted. Yes. So there you go.
Yeah, as much as I hate to say that, yes, it is true.
And I was just told that the Hubble telescope was rebooted recently.
I didn't see that. There you go. So kind of the next one I had was heartbeats. Heartbeats sounds similar to some of the air conditions and the dependency check, but it is a little different. So for heartbeats, think of it as a human heartbeat, right? It happens on a regular schedule. It's frequently, and it's consistent. So
they're kind of like the monitoring ping tools.
Yeah. So I typically, externally you could use something like Pingdom or Monitus, or there's a number of them where, hey, let's just ping your website, make sure it responds.
Techies make such great names.
They really do. But when I'm thinking about the system, I think really bringing these capabilities in and making them kind of a first-class citizen. So I just talked how amazing messaging is and how much it can help you. So the downside of messaging is my web server's up, my message queues are working, but that service that was supposed to be processing messages stopped processing messages.
Yeah.
And your end users are using screens, they're submitting forms, but then they go look for the data. They're like, the system's not working, but then I have an engineer go hit some of the pages on the front end, and they're like, yeah, it's responding. Right. It's super fast.
Yeah.
So now you're in this state where you're like, man, they're saying something's wrong. On the surface, everything looks okay. So we've used things like heartbeats to basically send like a tracer message, from one process, drop a message on a queue. The process that picks up the message from the queue receives it, then it writes it to a database, and then I have something else that then looks at the database to say, hey, every 5 minutes, do I see the timestamp updated? So that I know the entire process is working. Or you may have something that's scheduling tasks that's dropping messages on the queue. Same thing, making sure the scheduler is working. So this heartbeat lets you know there's a problem. It doesn't necessarily give you pinpoint accuracy as to what failed, but from the overall system, you know the system's running and you know all the components are online.
Yeah, in simple systems, there's tons of people that have just a website, database, and one offline job. And for instance, SurveyMonkey has one of these where you say, give me my survey results, and it says, well, we're working on it. We will email you when that big report is ready. Right, that's clearly asynchronous.
Yes.
And so your tracer bullet, your tracer message in that case could just be a API web request that then drops the message and then checks back. But in scheduled jobs, in complex systems, you got lots of entry points. So you're talking about orchestrating all the possible entry points so that everything is covered, right?
Yeah. Although I wouldn't say I want to cover every API. I want to make sure there's an entry point per process, from originating process. So that could be if you have a website, you have maybe a separate API host. Yeah, originate them from both of those. You have some sort of scheduler, originated from that. So you're really thinking at the process level.
Okay.
Is the process down? It's not to the level of trying to make sure every single line of code is executing perfectly. I'm really looking at some of these other capabilities and logging to dive into specific code paths.
Got it. Okay.
From there, kind of the next piece that has been really interesting for us is something we call data integrity checks. So, since we're talking about DevOps, I've fully bought into continuous delivery, which means, we're historically we deployed multiple times a day. We've started to back off that because we were changing so much for our users that it was making them uncomfortable.
Yeah.
But when I think about continuous delivery, if you're still working on quick cycles, you're going to use things like feature toggles to turn things on and off. So you can deploy it, but then boom, you turn it on, a feature lights up. That's the easy part. For me, it's okay. Let's say we turn a feature toggle on, and now the way we're storing data changes. We need to migrate data. Rules for what consistent data looks like changes. So we've actually come up with this concept, and we've made it first-class citizen again to be able to run health checks on our data consistency. So if I say, there's a relationship between one object in my data storage and another, and it always has to be one-to-one or one-to-many, we ensure that those exist by running more queries against the system that do kind of aggregate checks that look for outliers. And that's really helped us. So, if I have a really large change we're making to the system, we may deploy it incrementally over the course of 5 weeks. And over the course of the 5 weeks, the data integrity for those relationships change, and we actually put health checks in to make sure that it's doing what we expected, right? We're going to write code that's going to expect data be in a certain shape by the time it's deployed on the next release. So we want to make sure that we didn't miss anything.
Okay. And you also mentioned structured logging.
Yes.
At the beginning, which is different from regular logging.
Yes. So structured logging, when I first heard everyone talking about it, I was definitely the last person to buy in on it. I didn't see the value in it. We talked about logging performance to third-party calls, things like that. You can do that in both regular logging and structured logging. In regular logging, it just looks like you're writing the elapsed time in your message, and you have the information there. In structured logging, that looks like you write a message that says, I called into my database for this entity in this query. Then I have, think of it as if you picture it as a JSON object, right? You have a message property, you have a time elapsed property that is in milliseconds. You probably have a start time, which is a timestamp, and you have a end time in it. That's a timestamp. And once you have that structured logging going into a system that can receive that structured logging, you can start indexing it, and you can start doing things like, well, okay, let's find every call that's being executed in this code path to my customer's object or my customer's table. Now you can, with structured logging, say, let's plot the execution times that those took, right? So with structured logging, kind of gives you, it's like that next step that in order to do some advanced analytics, it's already done the parsing for you. So
this sounds like a fundamental shift, potentially, in the way that logging has been done since the late 50s, where you have a flat file where the first certain number of characters tends to be a time date stamp. And then you have just, free form for as long as whatever you want to put in there. But it's a flat file, and every row is a standalone message. You mentioned JSON. So it sounds like we're getting away from that paradigm if structured logging really takes off.
Yeah. I mean, the idea, you're basically paying the cost of parsing those messages up front, right? And by doing that, then you can use some more freely available tools to analyze that data versus, if I put all that stuff in just a single string message, now I have to go write code to parse it. I don't know if from release to release or week to week, we wrote the message consistently. So now I have like four parsers that then, based on the time it was written, it tries to do a different thing.
Yeah.
So, and that's, when I was just kind of looking through the logs manually, which, as the systems get bigger, you just can't do it. There's too much data.
Yeah.
So turning that data into structured data, now gives you the ability to run aggregates and queries across a time series. So you can now have, once you have something like this in place, you have a baseline. You can go say, okay, how did this execute up until the last deployment? After the deployment, is it consistent or something unusual? And we've used this again. I kind of mentioned we put decorators around everything that's external. Putting structured logging on top of that now gives us the ability to kind of do what we said. We, for instance, we use a lot of machine learning. So we were pretty early on using some of the Azure machine learning capabilities, and we noticed performance changes in the way Azure machine learning was returning results for us. So we were able to use the structured logging. We actually contacted the operations team for the Azure ML. We gave them all this information, and they're like, "Wow, you're right. Something has changed." It took them, a week or so, and they came back and they said, "Yeah, we identified the change. We didn't have that. We didn't notice that in our own metrics." So it was pretty nice to know, like, even some of the probably well-funded teams,
right,
in across the globe, we were able to, once we had this in place, we were actually giving useful information to them to help us.
So you mentioned JSON, but everyone's probably familiar with Log4Net or nlog, just for flat file logging. But you meant for structured logging, is there a library that you have that's a favorite?
So we actually use the SEQ sec.
Okay.
They have a backend service. We typically only use that for local development, but that they have a pretty good .NET library for managing and sending structured data into it.
Which is just hydrating an object and sending an object, right?
Yeah, it's really all.
And then it
all
serializes it into a JSON representation and writes it.
Yeah, it's really your backend service. So we're using a service called Loggly. There's probably 5 or 6 competitors that do the same thing Loggly does, and I've tried a few of them out. We're kind of happy with where Loggly is at today, but it's really the combination of finding that sec library that can write structured logging. And I think there's a few other .NET libraries out there. I think Patterns and Practices team a few years back started talking about structured logging.
Okay.
But you need the combination of being able to write it from your application easily. And in our case, that looks like an anonymous object. So, hey, I want to write performance data, write an anonymous object to pass it in the log entry. So it's not causing me to write lots of class declarations and other. You want to eliminate all the boilerplate code to make it as easy as possible. And that's worked out really well, where we can easily create new structured objects that get sent in. And then on our back end, using Loggly, they know how to parse it, they index it, they determine the data type based on the each field, what's going in there, and they have a pretty good kind of object browser, so I can go in and look for distinct values for any one of those fields. So it's worked out pretty well.
So I always like to boil it down for what people can actually do next, and so you got this team, and they have some pretty significant Visual Studio software, and they're listening to what we're talking about here, and they really want to do it. So are there any NuGet packages or tools or services in Azure where you say, hey, you know what, think of the 80-20 rule, just do it this way to get started in this?
Yeah.
What would your recommendations be there?
If they're not using Application Insight, that's a great way to start. That gives you a ton of capabilities that if you don't have anything right now, start there. Because as far as I think, like you said, that gives them a bunch of things without changing any code. Just by having the NuGet package installed, it kind of instruments your processes and it consolidates it. So, that's a great place to start.
Okay. And so if you do that, which of these categories do you get some coverage?
So I think that gives you coverage on your system metrics. It gives you some coverage on error conditions, potentially fatal errors, but it gives you kind of a full end-to-end, this is how things are performing. It actually covers some of the structured logging, and specifically what I mean by that is it gives you a lot of performance characteristics, right? So we're using a lot of structured logging to produce performance characteristics. If I didn't have that, I think Application Insights would be the way to go. And obviously the barrier to entry, I think it's harder to implement structured logging because it will take some time. You will have to at least dedicate one person, for whether you work at sprints or a pull system. They're going to have to spend some time to really understand it and put it in. Whereas Application Insights is literally install package, set up your keys, and deploy it. So so it's definitely an easier way to get started.
You did mention Loggly. Is that one where you would recommend it to anybody?
Yeah, I like it. They've as me being at a startup right now, I don't think we qualify as startup anymore. But they had some good entry level pricing. They were able to grow with us. So now that we're bigger, we can afford to pay some money.
Okay.
We were able to grow into more capabilities.
Now, if somebody has a sprawling system already, and they have N number of servers, and every one of them has a cluster of these flat log files, and so they're remote desktoping or using a terminal window to look at these files. What's a good technique just to take their existing flat files and start consolidating them all together so they can start a consistent view? Yeah,
so if you're in Azure, the OMS I think can help with this. Yeah, even if you're in Azure and you don't want to use OMS, tools like Loggly and their competitors all have agents that you can install. That you said that with some minor configuration, you say just start grabbing this log file and feeding it in. So it's a good kind of way to patch and get some of those capabilities, even though it wasn't built in.
So you can configure the path of where the log file is, and it will OMS and Loggly, they'll just pull it together. Yeah,
they'll just start reading it and start putting it into their central store.
Okay, awesome. And then your heartbeat. What is the source? What's your favorite source of the heartbeats? What kind of kicks it off and keeps that rhythm going?
So for us, we already had scheduling capabilities built in, so we just wrote on top of that. We were using Quartz.net. It's been around for so long that it was a no-brainer for us. We didn't want to write our own scheduler. So that's always a great way. Other ways to do kind of the heartbeats is, if you have an endpoint on your website or an API, use something like Pingdom or some third party to just call that endpoint on a regular basis, and then that could start running as well. So, there's multiple ways to get that done.
Awesome. Well, man, this was a mountain of information. Are there any other resources that the listeners should go check out for more information?
I think earlier you mentioned I did do a presentation to a user group on this. We can put that up there.
Yeah, let's put
but
a
I think
link
that
in
would
the
be
show notes.
that would definitely give a little more detail. But other than that, I think I've dug into a lot of the other big companies. Netflix has some great write-ups on logging and alerting. Because looking at companies that have documented this stuff on large scale, the philosophy and the principles still apply to small systems. You might not implement everything as intricate as they have, but it doesn't hurt to know what the big guys are doing.
Right. Okay, so we'll put a link to that in the show notes as well. Man, thanks so much, Eric, for visiting with me. This is fantastic. A lot of great information.
Thanks. I love talking about this stuff, so it was enjoyable for me.
And until next week, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.